This video is called Differential Equations and Continuous Exponential Growth, but really it's about this. E to the x. Remember that e is a constant. That's about 2.718. What is so special about e? Well, if our function is e to the x, then the derivative of that is e to the x itself. So that also means that if our function is e to the cx, then our derivative is our constant times the function itself. This will be important later. Okay, differential equations. So differential equations can be used to describe the rate at which the rate of change changes. So for example, let's say we have something that looks like this. What does this mean? What we're saying is that the rate of change of f is proportional to f itself. What might that look like in real life? Well, the growth of the coronavirus. Every person spreads it to, let's say, to a certain number of people. If that's the case, then the rate at which it grows has to be proportional to the number of people who already have it. The more people have it, the more people infect others. In other words, we can write it this way. The change in the number of people with the coronavirus, let's use n. N is the number of people with a COVID-19 infection. That's going to be some constant times n itself. Now, this is a classic differential equation. This is called a differential equation, diff EQ. We are trying to find a solution for n as a function of t that fits this equation. So remember that our differential equation looks like this. Okay, let's solve it. First, some algebraic manipulation. Next, we take the integral of both sides. Remember that this gives us and this is just that. To solve for n, we raise both sides to an exponent e, or rather we do that. This gives us some people who are astute might notice that, hey, we need a c here. I'm not going to call it c, I'm going to call it d for the constant that we get. If that's the case, then that means that we have something like this here. In other words, there's going to be a new constant over here by the properties of exponents. Here, the way this works is this is equal to this. So I can put this in front and call this n naught. Let's write this more clearly. So we got this function. This is n as a function of time. So what does this equation mean? Well, this is the starting number. How many people start by having the infection? And notice that we have exponential growth. The graph of e looks like this. And that's really the way, the number of people who are infected with the coronavirus, that's how it's been growing over time. So let's summarize what we've learned. Anytime we have a case in which the rate of change is proportional to the number of people. Example, COVID-19, the coronavirus growth. By solving this differential equation, we get this. What do we have? Exponential growth. So we know that if the rate of change of the number of people with coronavirus is proportional to the number of people with the disease, we must have exponential growth, which looks like that. That's it.